All right, and we are back to some great math today. Once again, a lot more factoring. That's right, that dirty, dirty F word in mathematics. We are going to F some things up in a real way today, my friends. All right, and you have permission to F it up real well. All right, so let's get started with today's work. Now, once again, you guessed it, we have our three warm-up problems there at the top. This is a review of all the factoring that we talked about in our last lesson. So once again, what I'd like you to do is just go ahead and pause the video, attempt these three problems, and then jump back on and we'll go through those, and that'll lead right into our conversation for today. So go ahead and do those three problems and then check back in with me as soon as you're finished. All right. Now, once again, to save time, I've worked our opener problems or warm-up problems on the next page here. So I'm just going to click over so you can kind of see the work, all right, and we can kind of check through that as we work here. Now, when you look at our first problem, there was no GCF, so we could put our A term in the upper left, our C term in the lower right. A times C is negative 24. Our B term is 2 to the x. All right, so 6 times negative 4 is negative 24. 6x plus negative 4x is positive 2x. Drop those in. You can see that our greatest common factor here is 1x. Our greatest common factor in our second column is a positive 6. Greatest common factor in our first row is a 1x. Our greatest common factor, now once again, notice both terms are negative, so we want to take that negative out, and we get negative 4. So our quadratic in factored form here is x plus 6 times x minus 4. Now, we look at our second and third problems. Both of these have a GCF. In our middle example here, we have a 2. So once I take out that 2, I'm left with x squared minus 11x plus 28. So once again, our A term is in the upper left. Our C term is in the lower right. A times C would be positive 28. Our B term here is negative 11. So negative 7 times negative 4 is a positive 28. Negative 7x and negative 4x is negative 11x. So I'm going to drop those two terms into our boxes here. And then our GCF working vertically here in our first column is 1x. Our GCF here in our second column is negative 7. Our GCF in our first row is a positive 1x. And our GCF here in that second row is negative 4. Now remember, we've talked about this a couple times, but if both of your terms here are negative, that implies that you're going to have to factor out that negative in both of those, so that we do a negative times a negative. This term here, if we were doing our area model, would turn out to be positive. Now, once again, when we write it in factored form, whatever GCF we took out in the very beginning, we need to drop down with us here. So 2 and then x minus 7 and x minus 4. All right, final example here. The GCF was 3, so you can see I have the 3 written out, which would leave us x squared minus 5x minus 50. So our A term is here, our C term is here. A times C is negative 50. Our B term, once we have that GCF factored out, is a negative 5x right here. So the combination we would want is negative 10 times 5, and then negative 10x plus 5x is negative 5x. So we're going to drop those two terms in here. Our GCF in that first column is 1x. Now, once again, you see that both signs are negative here, so we're factoring out the negative, and then the greatest common factor of 10 and 50 is 10. First row, GCF is 1x, and in our second row, it would be a positive 5. So our final version here would be 3 times x minus 10 times x plus 5. Now, hopefully this is starting to make sense to you, that we're really looking for a combination here, right? So we have to find A times C that tells us this number. And then we have to find the factors of that number that add to be our B term. And the great news is when we look at the work for today, so let me flip back to our notes here. All right, so we did all this, so let me scroll down a bit here. All right, so we can see the two examples here. What we're going to talk about today, all right, is when, all right, that A term is not 1. Now, the good news is the pattern does not change. The mechanics do not change. The only thing that changes is now, because this number is not going to be 1, all right, sometimes we end up with more combinations that we have to run through or check in order to find the one that works. So everything else is the same. So if we want to factor this, it's still a quadratic. It's still 3 terms. The A term still goes in the first box. So the A term is 2, maybe. Let's see if my pen can catch up with my the talking, all right, it seems a bit slow. So let's go back and do all this again. All right, I know you guys have heard that like for the 1000th time. So this is going to be 2x squared. So that still goes there. Our c term, which is 1, goes right here. All right. And so nothing changes. So the a term still goes here. The c term goes here. And we still have to do a times c. All right. So 2 times 1 is 2. So that is the combination here. Now we're still trying to get to the b term here, which is a positive 3x. So we have to find the factors of 2 that add to be a positive 3. And then, once again, we don't have a lot of choices. So we have 1 times 2, or we have negative 1 times negative 2. All right, and since we want to get to a positive 3, we're going to take the first selection. So we'd have 1 times 2 is 2, and then we have 1x plus 2x, all right, is 3x. And then just like what we did before, we're going to take these two terms and we're going to drop them into our area model here, all right? And there we go. Now, here's the big difference. Like I mentioned in the videos before, all right, because a was always 1, our GCF here always was 1x. Now that may not be the same. All right, so you can see here that I have a 2 and I have a 2, so the GCF for both of those would be 2. All right, and then you can see that we still have that x, all right, as a GCF between x squared and x. When I look here, my GCF is just positive 1. When I look at my first row, all right, my GCF here is just going to be plus 1x, all right? And when I look at my last row here, it's just a plus 1. So the mechanics of the problem do not change, all right? Just means that now our greatest common factor here isn't always going to be a 1x. It may not always be a 1x in our first row like it was for all the examples in the prior lesson. But all the mechanics, all the patterns that we talked about are the same. So our factored form would be 2x plus 1, if we take the top row there. And then off to the side here, we have our x plus 1. And there's our factored form. So the good news is that nothing has changed. Everything that we talked about in the prior lesson is going to hold true. And you'll see this in a few examples. It just means that we're going to get some more combinations to look at. All right, so let's go through number 2 together here. I'm just going to change colors real quick. All right, now I didn't mention it up here, but we always want to make sure we look for a GCF first. Now in the first problem, there was not a GCF to factor out. In our second problem, there's not a GCF to factor out here, which means we can jump right into that pattern that we established in our prior lesson. So my a term, all right, can go in this box. So 3x squared will go here. All right, our c term will go here. Now, so here's where, all right, the complexity comes in, because now we're doing a times c. Last time it was just going to be 1 times negative 40, and that was negative 40. But now you can see we're going to do 3 times negative 40, and that gives us a fairly large number. That's going to give us negative 120. All right. Now, we're still looking for our b term, and we still get our b term from this guy. All right, so if I come right over here, all right, our b term is negative 7x. All right, so now here's where the complexity comes in, because now we have to look for, all right, those factors of 120 that add to be negative 7x. So that takes a little bit more time to do. All right, so when we look at this, all right, sorry, I had to grab my notes to make sure I'm on the right problem. All right, so when we look at this, this is where the complexity comes in, because now these are going to be larger numbers. All right, and so that's where you might have to get out a piece of scratch paper. You might have to come over to the side and think about, okay, how do I multiply to get to 120, right? Now it's a negative number, so we know one number has to be positive and one number has to be negative. All right, and sometimes the easiest thing is to just get a calculator out and start going through the numbers that you know go into 120 until you find a combination that works or gets you close. So since it ends with a 0, let's talk about a couple things. One, we know that 2 goes into this number because it's even. We know 10 goes into this number because it's even. We know 5 goes into this number, or excuse me, 10 goes into this number because it ends in 0. We know 5 goes into this number because it ends in 0. All right, so there's lots of things that you will kind of start working through and seeing as you do this. And so sometimes you really literally have to just sit down and go, okay, so it's 10 times negative 12, right? And then so that means it's also negative 10 times 12, right? And then we know we're trying to, if I click back over here, we're trying to get to negative 7, all right? So neither one of those, all right, gets us to negative 7x if we think about adding them, right? And so you just have to kind of keep cycling through the numbers, all right? So and this is where the long part of factoring comes in. So the better number sense you have, usually the faster you go through this, all right? But the good news is there's only a finite amount of choices. There might be a lot, but they're finite, and you should be able to cycle through them, all right, eventually. Now, I've already kind of worked through this problem, so just to speed us up a little bit, the combination that we want for this particular problem is negative 15 and positive 8. All right, so negative 15x, and then plus, this should be a positive 8 here, my fault, and then plus positive 8x. There we go. Come on, pen, keep up. All right, gets us to negative 7x. And then you can see that we're just going to drop those in like we've done on our prior problems, right? So negative 15x here, all right, a positive 8x here, all right, and then we do our GCF. Now notice our GCF between 3 and 8 is still 1, all right, and our GCF between x squared and x is a positive x, so we just get that 1x right there. All right, now both of these are negative, so we're going to take out a negative. 15 and 40, the biggest number that goes into both of those is a 5. So we have 1x, and then we have the minus 5. We look this way. Now notice the biggest number that goes into 3 and 15 is 3. So we get 3 for our GCF there. And x squared and x, the GCF would be an x. And we look at 8x and negative 40. The biggest number that goes into both of those would be a positive 8. All right. So then if we write this in factored form, we do get just x minus 5. And we get 3x plus 8, and there's our factored form. So that's really the challenge with these problems is this a times c could give us some numbers that are a little larger to work. All right, so let's flip to the next page of notes. All right, and so let's look at our problem up here. And so here's what I would like you to do. I would like you to pause the video, and I would like you to try this one on your own. All right, your a times c is going to be a little bit large, but try to start with some combinations that you know and kind of work from there. So pause the video, give this one a shot, and then we'll go through it together. All right, so back at it. All right, so now when we look at this, there was no GCF. All right, so we can drop right into our work here. So 6x squared and minus 30. All right here. All right, and then that gives us a times c is a negative 180. So you can see that's a large number. And we have to add to our b term, which is an 11x. All right, and so when we think about negative 180, the combination that works here is 20 times negative 9 is negative 180, and then 20x, all right, minus or plus negative 9x is 11x. So that's the combination that we want for this particular problem. So now I'm going to just drop these guys into our area model here. All right, and then this is a minus 90 or minus 9x here. All right, let me clean up those signs a little bit there because that way we know what we have. All right, so that's a negative and that's a negative. So now when we look at our GCF in that top, in that first column here, it would be a 3 for the 9 and the 6, and an x for x squared and x. For 20 and 30, it would be a positive 10. For 6 and 20, the biggest number we can take out of there is a 2. And then for x squared and x, it's just an x. Now, once again, notice both terms in our second row are negative, so I'm going to take the negative out. The biggest number that goes into 9 and 30 is 3. All right, and so our factored form would be 3x plus 10, and our second factor would be 2x minus 3. All right, and that takes care of that particular problem. All right, now number 4 is a very specific example, and there's a couple things I want to point out about number 4 as we work this problem together. Let me, as soon as it stops sliding on me here, let's go back up here so you guys can see number 4. Come on, you can do it. All right, it doesn't want to stop in the middle. It just wants to keep going one way or the other, but I guess that'll work. All right, now, so when we look at number 4, the first thing is this does have a GCF. All right, so minimum, we know 18 and 32 are both even, so it tells us at least 2 goes into them. All right, so now when I look at 18 and 32, I'm going to take that 2 out. All right, and that's going to be a 9 and an x, and then minus 16. All right, so now, and I left my square off the x there. There we go. All right, so now we can put our a term here. 9x squared. We can put our c term here. All right, now 9 times negative 16, once again, gives us a fairly large number, negative 144. Now here's the other thing I wanted to point out. Notice there is no b term, there's no x term. So you have 11x here, we have 36x here, there's no x term. So that means we have to add to be 0x. All right? Now, in some ways this makes the problem easier for us because anytime we end up with 0x, what that tells us is that the factors of our numbers have to be opposites, right? Which means we're really dealing with a perfect square. And notice 144 is a perfect square. So anytime we have a 0x here, it's really somewhat easier because now instead of looking at all the possible choices that multiplies to be 144, there's only one that will get us to 0. And then it has to be perfect square. So 6 times negative 6, 5 times negative 5. Those are perfect squares, right? So the perfect square for 144 would be negative 12 and positive 12. And then that means negative 12x and a positive 12x. All right, and that gets us to 0. So anytime we have this 0x term, it makes this choice much easier because we know it has to be that perfect square combination. So I can drop that negative 12x into here. All right, I'm going to drop the positive 12x into this one. All right, and now we can look at our GCF. So for 9 and 12, our GCF would be 3. For x squared and x, it would be an x. Once again, both terms are negative, so I'm going to take that negative out. The GCF for 12 and 16 would be a 4. We don't have an x common anything, so we don't have to worry about that. The GCF for 9 and 12 is 3, and then we have the x for x squared and x. And then our GCF here would be a positive 4. And then notice our factors. All right, we have 3x minus 4. All right, and we have 3x plus 4. Okay, well, if you look at our notes, all right, and you can see that we get kind of a pattern here, right? So 3x times 3x, that's the 9x squared. Negative 4 times positive 4, that's the negative 16. Negative 12x plus 12x is a 0x. All right, so that's going to kind of work out. We call this the difference of two squares. All right, so when you see this, notice 9x squared is a perfect square, 16 is a perfect square, and that's something that we'll build a little bit more on. All right, so now if you notice, we have 3 problems left in our notes here. All right, and so what I'd like you to do is pause the video, work these 3 problems, all right, and then turn the video back on, and I'll go through these with you, and then we'll be done for the day. All right, now number 5, okay, if you had trouble with number 5, it's kind of a bad problem and a good problem all in one. And so the point of number 5, let me just switch colors here, and I'm going to try to scroll down here, is that it does have a GCF. All right, so there is a GCF here, and that GCF is 2. So I'm going to take the 2 out here. All right, and that leaves us 9x squared plus 18x, and then plus 16. All right, and so now the issue is this. You do your 9x squared here, maybe. Oh my goodness, my pen is like really off. Let's try it one more time here and see if I can get it to follow a little bit closer. All right, so 9x squared and 16, and then when you do a times c, you get 144, and we have to add to be 18x. Now the issue with this is that there is no combination. All right, so there's no terms, no factors that we can multiply to get 144 that also add to be 18. So this is it. This is all we can do. So this is the issue with factoring, is that it doesn't always work. All right, so this is all we can do for this particular problem. So that's why I said it was kind of a good problem and a bad problem. So we'll try not to do this to you too much, but we want you to be aware that not everything is factorable. All right, we're going to talk about something in a few lessons called the quadratic formula that will always work to help us find solutions. All right, so real quickly to go through 5 and 6 with you. All right, no GCF on number 5. So hopefully you put 4x squared in your first box here. All right, negative 18 in your lower right-hand box. All right, multiply 4 times negative 18 and you get negative 72. All right, and then you should be adding to get 21x. Now, the right combination to get you there would have been 24 and negative 3. And then you can see that 24x plus negative 3x is positive 21. So let's drop that 24 in right here, 24x, and negative 3x here. All right, so your GCF here would have been just 1x. Your GCF here would have been a positive 6. All right, your GCF here would have been 4x. And your GCF here would have been negative 3. All right, and so then if we write this as factored, all right, in factored form, x plus 6 and 4x minus 3. All right. Now, moving on to our last one, and we do have a GCF for this one, so we can take a 3 out. And if you take that 3 out, that gives us the 4x squared and plus 4x plus 1. All right. Now, notice if we had left it like this, when we did a times c, we would have gotten 36. There's a lot of numbers that multiply to be 36. But in this case, now our a is 4 and our c is 1, and we only get 4 when we multiply that. So that's another really, really, really big advantage of taking that GCF out first and recognizing that, is because now it makes this combination a lot easier, because a times c is 4. And then we have to find something that adds to a positive 4x as well. And that combination would just be 2 times 2. And we can see that 2x plus 2x is 4x. And so I'm going to drop the 2x in here. And I'm going to drop a 2x in here. All right, so then your GCF for the first column would be a 2 and an x. And then we have a plus 1 as our GCF for the second column. In our first row, it's also a GCF of 2x. And then in our second column, or excuse me, second row, it's just a positive 1. So then writing this out in factored form, we once again keep that constant out front, that GCF out front. So 2x plus 1 and 2x plus 1. All right. So that does it for factoring for today. So once again, you have the full notes to access if you need to. All right. If you need to look back on anything, good luck on the homework. Come see us if you have questions. We'll check you out next time. Take care of yourself.